Okay, now let's look at the last theorem, theorem 3, which is the main theorem or main result of this paper. So here we consider all codecs that have the structure of theorem 1 and 2. And we call all these codecs, we set off all these codecs, we call it CN. We claim that there is a codec in CN that has this additional structure, that for every two source sequences, Rn and Sn, that they map to two different channel sequences, Vn-1 and Wn, respectively Vn-1 and Wn-1. But the decoder at time n is the same for Vn-1 and Wn-1. So basically the mapping that happens at time n is the same mapping if decoder sees Vn-1 or Wn-1. So if that's the case, then going forward for times greater than n, all the decoders are the same and all the encoders are the same. Notice that we are not talking anything about encoder at time n, and we are not talking about previous times. We are just talking about time, encoder and decoder for timestamps after n, or n+1 and so on. So let's look at the proof of that. So let's pick a codec in Cn, again similar to theorem 1. A non-conforming pair Rn and Sn is a pair that satisfy 8, or equation 8, but not 9 or 10. Note that if Rn and Sn, let's say Rn is mapped to Vn-1 and Sn is mapped to Wn-1, note that Vn-1 and Wn-1 cannot be the same, because if they are the same by theorem 1, the result is, we have the structure. So Vn-1 should be different than Wn-1. Let A be the set of all non-conforming pairs, and we pick one from this set. And we make this definition. Here I define V of Z and U for Z in source alphabet and U in channel alphabet to be the set of all sequences, all sequence xn's, source sequences xn's, that they are mapped to Vn-1. They generate the channel sequence up to time n-1 that's generated is Vn-1, and the encoder at time n when it generates U when it sees Z as xn+1th element. And similarly, we define W of Z of U as all the source sequences that are mapped to Wn-1, and they generate U, or they map Z to U at the nth encoder. We define V without any subscript, or W without subscript, as the union over all possible Z's and U's of VZ, VZU, or WZU.